The eccentric geocentrist. Scribe grok patience. Clamp a session. Structured cosmos, pages of vibes of the cosmos. Layer. Foundational questions. Understanding the basics. These questions establish core concepts from the lecture, focusing on comprehension of the Tonto-world map, many Antarcticas, and Constellation Circle. Q. What is the Wide-Trail Map in Vibes of the Cosmos described as on pages? A. The Tonto-world map is a cosmic blueprint of the flat Earth, not a traditional geographic chart. It depicts the flat Earth as a structured plane with energy-defined boundaries reflecting the primary toroidal field's electromagnetic patterns. Q. How does the primary toroidal field shape the Tonto-world map? A. The primary toroidal field, an electrical Gaussian structure, envelops the flat Earth. Its energy loops converge at the center, creating a focal point and radiate outward, carving out energy zones like Africa-Europe and Sahara Desert, where the field's energy density peaks. Q. What are the many Antarcticas introduced on pages? A. The many Antarcticas are multiple ethereal zones at the edges of the flat Earth, possibly overlapping or layered, forming a protective or defining boundary around the central plane. Q. What role does the toroidal field play in creating the many Antarcticas? A. The many Antarcticas are localized concentrations of electromagnetic energy in the outer ring of the primary toroidal field. The field's electrical currents sustain these zones, with variations in energy intensity and frequency defining their distinct characteristics. Q. What is the Constellation Circle described as on pages? A. The Constellation Circle is a celestial structure above the flat Earth, where constellations are arranged in a circular pattern. It's a dynamic energy layer guiding the movement and appearance of stars. Q. How does the toroidal field relate to the Constellation Circle? A. The Constellation Circle is a secondary toroidal field above the flat Earth's primary field. Its electrical Gaussian structure creates a circular energy pattern, with electromagnetic currents moulding constellations as ethereal imprints visible as stars. Layer analytical questions, applying and connecting concepts. These questions encourage deeper analysis, connecting the toroidal field's mechanics to the phenomena described in the lecture and visuals. Q. How do the color gradients on the Tonto-world map page reflect the toroidal field's energy distribution? A. The color gradients, darker greens to lighter yellows, represent the toroidal field's energy density. Darker areas, like Africa-Europe, indicate higher energy concentration where the field's loops converge, while lighter areas, like Sahara Desert, show lower density where the field's intensity dips. Q. What do the red and purple lines on the Tonto-world map signify in terms of the toroidal field? A. The red and purple lines trace the toroidal field's electromagnetic currents looping around the flat Earth. They highlight the field's flow, defining boundaries where energy density peaks, such as between Central Africa and Western Desert. Q. How might the overlapping toroidal zones of many Antarcticas page create a complex energy barrier? A. The overlapping zones, shown as nested circles in the distance diagram's page, are layers of electromagnetic energy with varying intensities. This nesting creates a multi-layered barrier where each zone's unique energy signature e.g. higher frequency for coldness, isolates the flat Earth from external ethereal influences. Q. Why might stations like Vostok Station and a Davis Station in many Antarcticas page be positioned in different zones? A. Each station is in a distinct ethereal zone within the toroidal field's outer ring. The field's Gaussian distribution creates variations in energy intensity, so an Vostok Station might be in a higher frequency zone, while Davis Station is in a lower intensity one, reflecting the field's dynamic nature. Q. How do the electromagnetic currents in the constellation circle determine the circular pattern of stars? A. The currents in the secondary toroidal field flow in a circular pattern, guided by the field's Gaussian structure. This rhythmic flow aligns the ethereal imprints of stars into a cohesive ring, ensuring their stable, circular arrangement above the flat Earth. Q. What does the km distance marker on the constellation circle page suggest about its toroidal layer? A. The km marker indicates the scope of the secondary toroidal field, suggesting its energy extends far above the flat Earth. This distance reflects the field's Gaussian curvature, where energy density is sufficient to sustain the ethereal imprints of constellations at that height. Layer reflective questions, synthesizing and hypothesizing. These questions prompt critical thinking, encouraging students to synthesize ideas and hypothesize about the broader implications of the toroidal field in this cosmos. Q. How might the toroidal field's Gaussian curvature influence navigation on the world map? A. The Gaussian curvature creates energy zones with distinct signatures. Higher density zones like Africa-Europe might feel more stable for navigation, while lower density zones like Sahara Desert could be harder to traverse due to weaker energy flow. A navigator might follow the field's currents, red-purple lines to move between zones efficiently. Q. What role do the many Antarcticas play in protecting the flat Earth, considering their ethereal nature? A. As overlapping toroidal zones, the many Antarcticas form an energy barrier that shields the flat Earth from external ethereal disturbances. Their varying frequencies might deflect or absorb incoming energy, maintaining the central plane's stability within the cosmos. Q. How could the constellation circle's toroidal layer affect the visibility of stars over time? A. The toroidal field's electromagnetic currents might pulse rhythmically, altering the intensity of plasma emissions that project the stars. During high-energy pulses, stars could appear brighter. During low-energy phases, they might dim, creating a dynamic visibility pattern over time. Q. How do the world map, many Antarcticas, and constellation circle together illustrate the interconnectedness of toroidal fields in this cosmos? A. The world map shows the primary toroidal field organizing the flat Earth. The many Antarcticas reveal its outer protective zones, and the constellation circle is a higher field projecting the stars. Together, they demonstrate a nested system where each toroidal layer builds on the one below, creating a unified electromagnetic structure that shapes the entire cosmos. Q. Imagine you're a cosmic navigator in this toroidal cosmos. How would the interplay of these fields influence your journey from the world map to the constellation circle? A. Starting on the world map, I'd follow the toroidal field's currents to navigate energy zones, feeling shifts in density as I moved from Africa-Europe to the Sahara Desert. Reaching the many Antarcticas, I'd sense the overlapping energy barriers, possibly using their frequencies to propel upward. Ascending to the constellation circle, I'd align with its circular currents, using the star imprints as guides, while feeling the rhythmic energy pulses that sustain the cosmos' harmony. The eccentric geocentrist.com